Here was a request for assistance on doing the exercise for fundamentals of mathematics with decimals and percents. And the first thing we need to do is let's talk about place value. Okay, so we have a decimal that divides whole numbers and decimals. And this chart is very good because it shows you that tenths is one place value, hundreds is two place values, thousands is three place values, and 10,000s is four place value. We don't go past thousands. So now that we know place value, and this is units, ones, tens, hundreds, and thousands. On this side, we have a TH after after the words of rounding. So we can see in this guy, let me draw this, we can see that the TH is in the back of each one of the place values in reverse. In other words, we don't have zeros, we have tenths, hundreds, thousands, and 10,000s. And here we just have S after the word of the place value. And that's ones, tens, hundreds, and thousands. All right. So now let's get to the nitty-gritty of what you need to know to be successful. And that's the rounding rules. And our first step is to locate the digit. Now, a digit is a single number in the defined place value. Now, the digit that we're talking about is the set of 0 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the only digits that'll be in one place value. All right, we find the place value digit. And then the next step is to identify the digit to the right of rounding digit. All right, so we evaluate at this point. To evaluate, there's two conditions. The conditions are if the digit to the right is less than 5, that means it is 0, 1, 2, 3, or 4. If it's one of these, then, because this is an if and then condition, then you take action. Then rounding digit remains the same. Now the other condition, all right, now we got one, we're going to do the second one. Let me make more room. If the digit to the right of rounding digit value, I put value up there, so it's value. If the digit of rounding value is greater than or equal to 5, that means it is a 5 or a 6 or a 7 or an 8 or a 9. If it's one of these digits, then increase place value digit by 1. So now we've rounded to the place value. Write the answer that ends with the rounding digit. You don't put any other digits after that. So here we have to know place value. Then we have to identify the digit to the right of the place value. If that's 5 or larger, you add 1. If it's less than 5, then you leave that place value alone. And then you trunk off all the rest of the numbers. So let's do some rounding. And let me make this large so you can see. Round the number to the nearest thousandths. Okay, that's got a TH, so this is a decimal position. All right, so this is tenths, hundredths, thousandths. Okay, it's 3 decimal places. Okay, the digit to the right is 7. And we know that 7 is greater than or equal to 5. So increase 4 by 1. So the answer is 2 and 515 thousandths. And that's the answer. All right. So on this next example, we have, sorry about that, we have language, not a big deal. But I've got to make it smaller so you can see it. The stopwatch at the finish of the race displayed a time of 2 and 3,748 10,000ths hours. Round the time to the nearest hundredths. This is decimal value and 2 places. All right, so I'm going to write this here. And we're doing hundredths. So 4 is the digit to the right. Of the place value. It's a digit to the right. And 4 is what? Less than 5. Therefore, rounding digit stays the same, no change. So this one is in the rounding 2 and 37 hundredths hours. That's what you'll round it to. And on a race, they go to nanominutes in some cases. Okay, now we have another example. And in this one, again, there's language. On average, patients visit their dental hygienist once every 223 and 615 thousandths days. Round the figure to the nearest whole day. That means we're rounding to ones. Right. So my number, I used the wrong pinpoint, is 223,615. We're rounding here to that. And we're evaluating with this digit 6. 6 is greater than or equal to 5. Therefore, increase place value by 1. So that would make it 224 days. And it's approximation, and it's pretty accurate. Okay, we're now getting to simplify fractions. And this is probably the area that's given you the most hardship. And we're going to make it simple. Okay, that means to divide the numerator and denominator by a shared factor. That means a number is a single number, but you're doing it to both the numerator and denominator, that divides evenly into numerator and denominator. All right. So the ones that you have on this exercise are easy. We know they end in zeros. Therefore, we're going to divide by 10. And that makes it a 1 right there. Now, if I divide by 10, I get a 5. And if I divide by 10, I'm going to get 11. And this we can't do anymore because 5 and 11 are prime numbers. That means their only factors are 1, 5 times 1. So we're done. Now this one is very interesting. It addresses, I should say, the divisibility rules. Divisibility rules say that if I have a number and I divide by 1, I have the number. That means you can divide any number by 1 to make it look like a fraction, and you'll get the same number. If I divide any number by itself, remember that a cannot equal 0. There's no 0 in a. Then I get 1 because I'm dividing by the same digit and sign. Okay. The first one's identity. The second one is what we use to multiply a fraction by to get equivalent fractions. Then I have this one, 0 divided by any number is 0. You can divide into 0, but you cannot divide by 0. So any number divided by 0 is undefined. All right. Well, right here, we're dividing by 0, so it does not exist. And you'll get that, and it does not exist. And you can double check with your calculator, and I'll call it up so that you can see. And I want to say that number, I push it over here. Whoops, sorry. Sorry. And we had, let me put on the other side. I'm covering my numbers. There it is. 936 divided by 0, and it'll say error. See how it says error? And it can't be done. So then you know it's undefined. If you can't use your calculator, double verify to make sure you understand. Now, converting percents to decimals. Well, we know, this is what we know, that a decimal is in place value. And the place values that I showed you above gave us the fraction. Let me go back up there. Don't get us, yeah. See how it's whatever number over 10. This one is whatever number over 100. So these two numbers are over the 100. These three numbers are over 1,000. These four numbers over 10,000. All right, and that tells you what you have. Now, let's go back here and say, okay, decimals in place. Oops, sorry. Where did I put you? Oh, there we are. Sorry. So now let's look at what I'm doing on you. Sorry, I got lost there. Okay, to get percents to decimal, there are two ways. It depends what school you came from. This is visual decimal movement. So if I have a percent, say I have 55%, I cross out the percent and I put a decimal and move it 2 places to the left. So this one would be decimal 55 when we convert a percent, because it's part of 100. All right, that's one way. The second way is to take the percent value and divide by 100. So what happens here is if I had the 55%, I divide by the 100%, the percents are gone, and I stick this in the calculator, and I get 55%. You may do it any way you choose. Write the percentage of a decimal number, 2%. So I have 2%. I'm going to cross it out. I'm going to place my decimal. I'm going to move it 1, 2 places and insert a 0 placeholder. So this one in decimal is 02. All right. Now, if I did it by calculator, I would have 2 divided by the 100, and I would get the same answer. And you can see that on my calculator. And we're going to say quit on that because we know it's wrong. And we're going to say 2 divided by the 100. And that gives me the decimal of decimal 02. All right, now this one is, what is a percent equivalent to 1? Okay, to have 1, have 1 come out of a percent. This is the decimal representation. Means that I have 100%. Now the reason we can say that 100% is 1 is we can cross out our percent, put a decimal, move over 2 places, and we get 1. 100% is all. Well, what is, if we know that, then we can say 2 is 200%. That's double. Triple is 300%. And we use these large factors when you're talking stocks and bonds and how much money you've made on a particular purchase of stock. Now they want what is 4% as a decimal number. All right, 4%. We're going to cross out the percent, put a decimal, move over 2 places, insert a decimal point, and this is what we get. If we did it by calculator, we would have had the 4 divided by the 100 and gotten the same thing. Write the decimal as a simplified fraction. All right, well, this is 100, so this would be 62 over 100. We know that 0 and 2 are even, so I'm going to divide by 2, the numerator and denominator. That'll give me 31 over 50. 31 is prime. There's no numbers that multiply evenly to get a 1 as a product. So we're done. Thank you for listening.